Good morning. Welcome to the 7th, 8th, 9th, 10th, I'm not sure which one it is, but virtual meeting, which for the Denver ISSA. It's May 28th, and our presentation today is on cloud security monitoring, which is a very crucial issue given all that has happened and the need to move to the cloud, especially for people working from home and able to get access at all times. My name is Teresa DeGroat. I am the Director of Membership for Denver ISSA and would like to urge you to continuously look at all the different programs that we're going to be running. We're running 2 per week, definitely through the end of June and perhaps beyond. It's a wonderful way to generate CPEs with basically from the comfort of your office, living room, deck, wherever you're watching this from. So I'm going to get this started and introduce our speaker today, Michael Wylie. Michael is the Director of Cybersecurity Services at Richey May Technology Solutions. In his role, Michael is responsible for delivering information assurance by means of vulnerability assessments, TPN vendor assessments, cloud security, penetration tests, risk management, and training. Michael has developed and taught numerous courses for the U.S. Department of Defense, DEF CON, Moorpark College, California State Universities, and for clients around the world. He is the winner of the SANS Continuous Monitoring and Security Operations Challenge coin and holds the following credentials: CISSP, CCNA RNS, CCNA Cyber Apps, GPEN, GMON, TPN, CEH, CEI, VCP, DCV, CHP, Pen Test Plus, Security Plus, Project Plus, and more. So without further ado, I'd like to turn this over to Michael. And Michael, why don't you take it away?
Thank you very much. And thank you everyone for joining. So I want to start off with my dream here. It was to have my own overly exposed viral cybersecurity acronym, one that you would use when you're at DEF CON or Black Hat or other security conferences where people would want to drink when that name was, or the acronym was overly used. So I came up with Continuous Cloud Security Monitoring, or CCSM as I called it. Unfortunately though, what happened was, as I started researching that, is that I realized that my acronym of CCSM, after building the slides and coming up with everything, was unfortunately stolen by Coca-Cola. Apparently they have Coca-Cola signature mixers, which they abbreviate CCSM. So that dream was gone, but the presentation lives on. So a little bit about myself. I am the Director of Cybersecurity Services here at Richey May Technology Solutions. Former DoD contractor where I taught numerous courses in offensive and defensive security. Former business owner before my company merged with Richey May Technology Solutions. It was a boutique cybersecurity firm here in Los Angeles. Now day to day, I run the content security program for Richey May, which essentially helps content security for studios, vendors in Hollywood here. Also volunteer for the Marine Corps volunteer cyber auxiliary unit. Also teach in some of my free time for local universities and colleges. And I am one of the first qualified TPN assessors in the media and entertainment industry. So before I get started with some of the basics that we'll talk about through CSM, I wanted to first talk about the difference between CSN and a term that you're probably familiar with, NSM. So what are some of these differences? Well, when we talk about NSM, or network security monitoring, we're talking about the collection analysis of network data to detect and possibly respond to intrusions. The data sources that you might use in NSM, if you've read any of the books there on the screen, might be full packet capture, which is one of my favorites, NetFlow or SFlow data, alert data, firewall log data. And the focus of NSM is really on data in motion, data traversing your network. Tools you might use for this, possibly a firewall, security onion, Bro, etc. With continuous security monitoring, or CSM, it's the ongoing automation of detecting and responding to cyber threats. So continually reassessing security postures, not just a single time, but over and over again, and looking ways to improve that. Keeping up with challenging threats, vulnerability landscapes, the ever-changing landscape that we take a look at. And looking at trying to get an increased visibility into both ourselves as well as our threat actors we may face. The goal is timely incident detection, right? Decreasing dwell time. The focus is on data at rest rather than in motion, which it was with NSM. So if we look at NIST SP 800-137, it states information security continuous monitoring, or ISCM, is defined as maintaining ongoing awareness of information security, vulnerabilities, and threats to support organizational risk management decisions. And some of the highlights of this, if you don't want to read the large document, it defines the ISCM strategy. It establishes a program, implements the program, analyzes data and report findings, responds to findings, reviews, updates the strategy and program. And so now let's take a look at the introduction to cloud security. There's a lot of newsworthy breaches that we see, and they don't change. I actually got tired of updating the slide because it felt like every time I gave the presentation, there was 5 more that I had to add. So I stopped at the end of last year. We saw 2019 Capital One, over 100 million records were compromised or breached. 2019 also Lion Air, millions of records. Another one, 2019 Facebook app providers, they had a breach with 540 million records. 2017, Booz Allen Hamilton, there were some admin credentials and battlefield imagery that were leaked. 2017, U.S. voter records, there was 198 that were leaked. 2017, Dow Jones, they lost 2.2 million records. 2017, Verizon, I believe that was with an S3 bucket, 6 million records. Time Warner Cable in 2017, 4 million records. And it's not just the big players. I like to put the big names on there because they had a lot of data, but it's also some smaller organizations. So if you're a smaller shop or a smaller organization than, let's say, Verizon, you're still at risk. We can see that a small credit federation, National Credit Federation, they lost 47 million records. And so if we have different cloud platforms, and one thing I do want to note is that I'll primarily talk about AWS type security just because I'm the most familiar with it, but a lot of these concepts that apply in this talk here will go across all different platforms, whether you're using Alibaba, GCP, Azure, etc. So if you look at the different cloud platforms that you might be interested in or that you're playing in at the moment, they all have a shared responsibility model. And this is an overly used diagram in a lot of cloud security talks, but I feel like we're still not getting it right. And so I'm going to keep putting it in my slides until I see improvement in this area. So whatever cloud platform you're working on, it's important to understand where your responsibility is and where the provider's responsibility is for security and what they're going to focus on, what you're going to focus on, and where there might be some gaps. And I think the AWS shared responsibility model that's on the screen here, they kind of generalize it, but obviously each service that you may or may not use is going to have a different shared responsibility model. So for example, in EC2 instance, you're going to have a lot more responsibility than AWS. Whereas if you talk about something like Lambda, where it's more heavily on the AWS responsibility, the responsibility is going to shift and you're going to have a lot less that you're responsible for. So not just for the cloud platform, but the services you use, it's important to draw this out and pay attention to what you need to focus on and any gaps you might have. Similarly, Azure, I think they did a little bit better job, in my opinion, breaking this out, although there are so many services that within each one of these columns, like SaaS, PaaS, IaaS, and on-prem, you're going to have different services and offerings that may have different responsibilities there, but they tried to generalize it in a little bit more detail than AWS did. So you can see if you're using a SaaS solution that the Microsoft is going to be a little bit more responsible for things all the way up to identity and directory infrastructure. Whereas if you did something like IaaS, you're going to be responsible for those things, including possibly network controls and the operating system. GCP broke it out a little bit as well like this with IaaS, PaaS, and SaaS, and where you're responsible. So again, the point of this is just to understand which platform and which services you're using, where you're responsible, and what you need to pay attention to. Within each of the major 3 cloud providers, they have a lot of solutions that are even built in. Yes, there are tons of commercial products that you can purchase to make your life easier, and you can go down a rabbit hole of different shiny balls that you're chasing and play with these different tools. But there are a lot of built-in security features. And this slide isn't meant to show that AWS has more than Microsoft Azure or Google Cloud Platform. Again, I'm just more familiar with the different tools in AWS and how I use them. So I listed more of those tools. So they've got different things for API calls, configuration state, system logs, threat events, vulnerability assessments. You can run vulnerability scans built into these cloud platforms. Microsoft, they've got tools for system logging, configuration state monitoring and detection, direct activity, vulnerability scanning. With GCP, you've got built-in tools for the same thing, API logging, system logging, vulnerability assessment continuously. And so if we look at some of the stuff, this slide's a little bit dated now that some new reports have come out, but if we look at our dwell time, it's been horrible in the past and it is getting better. But even if we look at external notifications from the time there was a breach to the time that we actually detected that breach, we're still at 184 days for that external breach. For example, an S3 bucket that might be leaky. And so another problem that we have here is alarm or alert fatigue. And those of you who've been in this for a while, you may see it as a real thing, but yet I still see this as a common problem and something I deal with on a daily basis as we help our customers. So if you just Google alert fatigue or alarm fatigue, it basically states that alarm or alert fatigue occurs when one is exposed to a large number of frequent alarms. And it basically leads to longer response times or missing important alerts. This couldn't be more than true. Even though it came from Wikipedia, it's fact. So here's an example of a SIM that I looked at. It seems like the last month or two, and I believe that's because of all the work from home, I've been put on a ton of logging and SIM projects and a few incidents here and there. And so this is a screenshot of one organization where they're logging things within AWS with their cloud environment. And I took a look at their dashboard, and while it looks pretty, and back in the day when we had SOCs and NOCs that were to physical location rather than remote working, you'd see something like this on a giant screen or a plethora of screens inside the office, and it looks awesome. You see the heat map, you see account, pie charts, all this stuff that looks awesome. And it looks like, wow, they're doing a whole lot of security stuff here. Well, when you dive into some of this stuff, though, and you look at, for example, there, the box that's in red, it says 28,000, over 28,000 events. The time frame was the last 24 hours. And what event was that? Well, it was VPC flow rejections. So essentially denies. Well, my question here then is, how is that useful? How can any of my security engineers or analysts or anyone on my security team take a look at this and say, this is useful information? And some people may find valid reasons for this. And if that's the case, keep it up there. But I see a lot of this. And the point of the slide is that we have all these alerts and things that are going on. And what happens is that your email box fills up, your ticketing queue fills up, and you start ignoring that. I've been guilty of that. My team's been guilty of that. People we consult with have been guilty of that. And the thing that we need to focus on is how can we make this actually something that's actionable rather than 28,000 events? And maybe when I compare 28,000 events to yesterday, when it was 5,000 events, that's meaningful to me and I can act upon that. But just taking a look at this at the customer's dashboard and seeing 28,000 rejected events, I can't do anything with that. Likewise, I've seen a lot of IDS solutions, and even now they're getting pushed out. IDS and EDR pushed into the cloud environments, and they'll have things like, our IDS detected 5,000 SYN floods this week, and we blocked their IP address. And I kind of look at that and think, well, how do you know it was theirs? How do you know they didn't compromise in their system? Or maybe they didn't block it. They just tell me that 5,000 SYN floods have been targeted at their organization last 24 hours. Well, again, what am I going to do with that? How is that helping our security posture? So I already am going to run out of time with my slides. I can never get them all in time for this topic. So if you want to learn a little bit more about some of those things that I did, there's I think it's out there on YouTube or Eventbrite or Bright Talk. I've talked about this before with ISSA webinar. I talked about proactive and response to events and how you can get a little more proactive rather than reactive and escape the vicious cycle of being reactive. So if you want to Google that, you can see some of the things I talked about during that webinar. So some of the things I want to talk about here for this talk is that the concepts, as I mentioned, are neutral, cloud platform neutral. They are going to work across AWS, Alibaba, GCP, but I'm going to use a lot of AWS use cases just because I'm more familiar with that. We're going to talk about monitoring a non-defensible cloud and what that looks like, some inventory control, vulnerability management, some least privilege best practices, secure configurations, monitoring and logging of our environments, and detecting high fidelity events, which is the most important. And if I run out of time towards the end, I'll probably gloss over the monitoring and logging piece because that was part of my presentation last year at RMISC. Okay, so let's talk about monitoring a non-defensible cloud. Going back to NIST 800-137, the Information Security Continuous Monitoring document, one thing I wanted to point out here is that if you look at Chapter 1, the very first part of this document from NIST, and highlighted there at the bottom, it says, maintaining situational awareness of all systems across the organization. That's you. Maintaining an understanding of threat and threat activities. That's the bad guys. Now, why is that important? Because that goes back to my favorite quote in cybersecurity. If it comes from Sun Tzu, The Art of War. If you know the enemy and know yourself, you need not fear a result of 100 battles. If you know yourself but not the enemy, for every victory gained, you will also suffer a defeat. If you know neither the enemy nor yourself, you will succumb in every battle. And I think this is important for cybersecurity, even though it wasn't written that way, because we need to both know ourselves and what normal looks like for us. And if we do that, and we also start paying attention to the bad actors, then we can identify evil. So know normal, find evil. Okay, so is this normal or evil? And normally this is the interactive part of the talk, but obviously being virtual with COVID-19, it's a little bit different here. So I'd ask organizations in their environment, if a new instance was spun up in AWS at 3 o'clock in the morning in South Korea, would that be considered normal or evil? And I get all kinds of different answers normally when I ask for feedback. Some organizations say, that's fine. We do work 24/7. We're multinational. Other organizations say, no, we have one shop, but it's in Colorado, and we don't use any of the regions outside of Oregon. Okay, so that might be evil or it might be normal, but it really depends on your organization and knowing yourself. 50 new instances don't have names or tags. Is that normal or evil? Some organizations say, well, we don't name any of our instances, so that's normal. Others say, no, it's required by policy and procedure that we have all these different tags on all of our instances. So that is maybe not evil, but that is suspicious, or it's something we need to dig into. You have PS exec is run on one of your servers in AWS. Is that normal or is that evil? Right. And this goes back to one question that a SANS instructor once told me, and I absolutely love it. They said, what is malware? How do you define malware? And going deeper into that, they say, well, and students come back and they'll say, well, it's software that's malicious, or it's something like WannaCry. And sure, we can all agree on that. But then the instructor said, well, what about PS exec? Is that evil or is that good software? And two people will say it's normal. I use PS exec, and everyone else says, no, it's evil because we always see the bad actors using PS exec. So it really does depend. And so seeing that would also depend. And that's why it's important to know your environment, know yourself, and then also know the bad guys so you can pay attention or find those evil instances within your cloud environment. Okay, so I'm going to skip some of these other examples since I don't have any feedback from you. So how do we build a defensible fortress? Right? And so I go back to the time that my wife and I went to India and we visited the Agra Red Fort. And the first thing is we did the tour and we started learning about some of the defenses. It came to me as like, this is exactly what I need to use as an analogy for cybersecurity. When we visited this fort, when you walk in, there are thick, high walls, and you can see the little holes here and there for archers to shoot bows and arrows or whatever weapons that they had. There was a large bridge. It was a drawbridge that they could bring up or down depending on the level of risk. They had water in the moat with crocodiles. That was the wet moat. There was also a dry moat that had tigers as well. So there's two different levels of moats. They had layered corridors. So once you walk through the entrance there was other doors you had to get through with high walls. And so you could be trapped within those little segmented pieces within the fort. They were, when you get into past, I think it was the third or fourth door, there was a long hallway with, again, tall walls. And to get towards the center of the fortress, they were sloped upwards. And so what was described to us is that these narrow hallways, what they would do is that if there were enemies that got that far, they would roll down boulders, basically crushing people. And there was also holes in the upper area where they would drop down hot or boiling oil, and they would pour that down. So it would be slippery. It would basically boil people alive, and then the boulders would crush them as well. And then they had controlled ingress and egress points to every doorway. And so going through that, I kept thinking, this is what we need to think about for our organizations and having layered security. This is absolutely layered security. Every time you hear about that, from your Security Plus, your CISSP training to NIST, everything, we talk about layered security. And this is a true demonstration of how that's been being used for hundreds and hundreds of years. So another piece, and we talk about segmentation within the Agra Red Fort. Well, there's also, we can have segmentation within our environment. We have, most of us have segmentation within our corporate networks on premise. We've got a production network, an IoT network, a CCTV network, a guest network. Likewise, we need to have segmentation, not just of networks, but accounts, servers, all kinds of different things within our cloud environment. And so this illustration here, the diagram that I've got on the screen, is essentially what AWS just recommends. It's basically popped out of their documentation for PCI compliance and what they recommend. So they can see that you can separate it with different VCPs, you can have different ACLs, subnets, et cetera, but that absolutely needs to be something that we focus on. Just plop all of our instances and all of our resources in the cloud into a single network. So having that segmentation of accounts, networks. I know I've went to a talk with Netflix and some of their security engineers, and they were talking about how they segment not just networks, but even accounts. And so they've got an account designated to production and nothing ever changes there and unless it's pushed through all these change control procedures. But then they've got other accounts for PCI, they've got other accounts for testing and this, that, and the other. So they don't even let those accounts talk to each other because they're concerned about lack of segmentation there. Least privileged, change control, inventory of systems and services, continuous security monitoring, detecting and preventing controls are all things that are important for a defensible cloud. I just want to show you a quick diagram of this, a basic diagram that we use for the media entertainment practice, since that's my primary focus here at Richey May. I work with studios and vendors to help protect content so it doesn't get on Pirate Bay is basically the gist of it. And so this is the abstract or the high level of how we set up diagrams. And this has been generally agreed upon with most studios in the industry, the big names that you know of that are making those blockbuster hits. And this is if you are a vendor. So if you're working on sound correction or color correction or mastering sound or visual effects or anything like that for the studios, working on something that's high value to them, this is what they generally agree as the best practices for segmenting your network. Whether it's, well, they're not too big on the cloud quite yet, but at least on premise, this is how detailed they want the segmentation. They want, if you're going to do any remote work, they want a VLAN, a network just for Bastion hosts, for a jump box for remote workers. They want a segmented VLAN for internet usage, another one for services like your domain controller, file servers. They want another one for what they call the content network. And that's the one that works on production content, like the actual movies that you watch. And in that network, it's completely, I don't say completely, but it is air gapped from the internet. You are not allowed to have even pinholes for Microsoft updates, for Apple updates, for Adobe updates. All of that has to be completely controlled through a proxy server. And any data that comes in and out of that content network is going through what they call an IO network or an ingest-egest network. And on that network, you've got machines that have limited access to the internet. So it's a deny rule on the firewall for everything. And then you're only allowing things like access to updates or access to studio file transfer servers and things like that. And obviously you have other VLANs for things like DMZ and your security team and stuff like that, but it's heavily segmented and there's layers of segmentation so that content cannot touch the internet. That's their high value. That's their crown jewel, if you will. And that's protected in an air gap network or close to it. And anything coming in and out is controlled through ACLs, one way, heavily monitored, kind of like the drawbridge going to the Agra Fort. So let's talk a little bit about CIS best practices, right? These have been talked about a long time, but I still don't see organizations even hitting the top 3. Okay, so the CIS best practices and benchmarks and stuff, it was originally developed by SANS Institute, but then it was passed off to CIS. It's basically a response to an increased breach of incidents. And they decided, and I think this was just genius, and I've been trying to apply this to many different areas of security. They decided to come up with the top 20 controls to make defense easier. And within that, they also did benchmarks for secure configurations. And they provide those for free. You can get the GPOs or other things, you can pay for those, but at least for the benchmarks and the PDFs, they're long reading, but they are there for free for you to download. So basically they took 100 different contributors, places like US CERT, US DoD, MITRE, SANS, et cetera. And they all came together and developed these benchmarks and these controls. And they've been building on those since then. So if you haven't seen version 7, not only did they take the 20 best practices, but they broke that down even further because I guess people still weren't able to do the top 20. So they broke it down to basic, foundational, and then organizational. And so they said, okay, you can't even do the top 20. And these top 20 things are going to prevent you from a ton of breaches, ton of incidents. Focus on these top 20. Can't do that? Fine. Focus on the top 6. Just get these basic 6 things down. Focus on that. And I think that gives bite-sized nuggets to organizations and where they need to focus. So these are the controls, right? And thinking about these, they apply to on-prem, they apply to cloud platforms, they apply all over the place. You can take these concepts and apply that. But if that's not enough, they also have which a lot of people don't know about when I bring this up, is that the CIS also has their cloud controls. So they are heavily focused on cloud rather than just generic security best practices. Things like inventory and control of hardware assets, inventory control of software assets, continuous vulnerability monitoring. They go on and on. They talk about cloud-specific things rather than just general. Okay, and then so let's talk about a little bit about inventory control and how you can apply some of these practically to your cloud environments. Okay, and so a lot of times I've got many different AWS accounts for different things, like the universities I teach at, for lab environments, for clients. So I have a lot of accounts, and within those, I can see how easy it is to get lost in the amount of services and the things that you purchase on demand or you use on demand within the cloud environments. It's gotten better. There's been improvements, but I definitely remember early on when I was using AWS, when there was far less services, I would spin up an EC2 instance and I would use it and I would tear it down, terminate it. Great, I'm done. I used it for 5 hours. I'm only going to pay a couple of pennies. This is the beauty of cloud, and I'm done. And then I would start getting bills for stuff and say, how am I getting a bill? I terminated these services. And so what I found out then is that, well, yes, I terminated the instance, but I still had the elastic IP address. I had the storage. I had all these other services that were modular or integrated into my EC2 instance that were not terminated. So I still had a terabyte of storage I was paying for. And so keeping an inventory of those things, traditionally we think of inventory control as, well, how many laptops do we have? Where are the laptops? When we terminate employee, are we getting those back? Keeping track of your assets that way. But in the cloud environment, these are on-demand services like virtual servers, virtual storage, virtual this, virtual that, and all these things we need to keep inventory of. And it can be challenging because AWS is modular and they have things that are integrated. And so using some type of third-party tool may help you out. I'm not advocating for one or the other, but I just did a screenshot here of Cloud Checker, and it shows you, and I was even shocked, this is my teaching account. And when I looked at it, I thought, wow, there I have no running instances, yet I have an EBS volume and it's sitting there. So I didn't even know I had essentially a virtual hard drive sitting there that I was paying for. I knew I had some buckets, but there was no way I realized that I had 161,000 objects in those buckets, and that it was equivalent to 16 gigs of data. So even on a very small account that I just used for some demonstrations, you could see how that can get out of hand. CloudFormation, I didn't even realize I played with CloudFormation. I had 2 CloudFormation things there that I was running. So being able to get a real-time view of this and something that's constantly checking your environment and giving you feedback of that, you can look for changes, you can look at increases, and you can kind of inventory of what you have. And I wouldn't really call it hardware or software inventory, but just inventory of cloud stuff that you're paying for. Another thing that might be able to help with this, each cloud platform has their own version of this, but I happen to like Terraform just because it works across Alibaba Cloud, AWS, GCP, Microsoft Azure, OpenStack, etc. And so what this does is that if you use Terraform, you can use many use cases for it, but I like it for the fact that it can help with building, changing, versioning of your infrastructure safely and efficiently. So you can build out rather than going around in AWS and clicky here, buy this, purchase that, on demand this, is that you can configure what you want in a configuration file, a Terraform file, and you can plan, execute these deployments, test them. It minimizes human error. It when you're done with these things, let's say if I was building up a lab environment with 20 instances for my students, then I don't have to remember to go and now get rid of those 20 elastic IPs or those 20 EBSs or the 20 everything else. I don't have to go back and try and figure out what's missing. I can use Terraform to spin up 20 instances and then tear everything back down when I'm done with that. And then you can override any unauthorized change. So if your team or someone or DevOps, let's say, is in your AWS account or your GCP account, and they make changes that weren't authorized, that didn't go through change management, Terraform can basically revert things back to that known good state that was approved and went through change management. Right. And that can help with things like this. So last year at RMISC, I gave a talk about AWS cloud security on the dollar menu, and we talked about setting up billing alarms and some of the issues that we saw with our customers as well as just the public. And it was VM sprawl, account takeovers, and we saw many cases where accounts were compromised or employees did things and bills went higher. I remember getting hired for one job with a client, and they said, we've got a $250,000 a month bill, and we have no idea where it's going. And I'd find things like $5,000 a month was going to a SAN that was no one was using, and no one commented or talked about, and no one knew where it was. And so as you dive into these things, the ability and the scalability of cloud environments is awesome. But the downside is that anyone can go ahead and just spin things up and start paying on demand. It's like giving a kid a credit card in a candy store, right? So whatever they want, they can go ahead and buy. Whereas traditionally with on-prem, we had to go through a PO process. We had to go through all these layers to get the server set up or services set up. Now it's easy just to click things and basically buy whatever you want. Okay, and so if we also look at, I know the 2020 report just came out, so this one's a little bit dated, but I didn't have time to update it. The Verizon 2019 DBIR report, it also shows that we saw an uptick there between 2017 2019, that the orange column there, or the orange line, is showing us that system admins are actually an increase of causes or the actors in the breaches that Verizon reported. And so one of the things there, I don't want to think that all of our insiders are bad or that we're starting to hire worse people. I think that trend and that increase that we're seeing there in percentage, a significant increase, is actually related just to mistakes, right? So it doesn't report whether these breaches were caused by insiders because of willful or unwillful acts. I just think that there's things like cloud and possibly making an S3 bucket public, and that's why the breach happened. It was just an honest mistake there. So we can see, though, that data is showing that that internal insiders like system admins are attributing the cause of some of these breaches, and they're going higher and higher and higher as part of that pie chart. Right. And so as I mentioned, billing alarms can help with that as well. They're easy, it's free, it's things you can set up. The one downside to setting these billing alarms is that when you set them up, it's not going to alert you until you hit that threshold. So if you say, for example, $10, I want to be notified when I hit that threshold. But let's say that your normal cost in AWS is $9 throughout a month. You set the billing alarm up, day 2 of the billing cycle, you get an alert saying you've hit $10. Well, that means that something went wrong and you've been billing and you got alerted, which is great, rather than waiting till the end of the month's time. However, that damage has already been caused. You've already hit that $10 threshold. And that might not seem much. You lost $9. But if you can think about an organization where your average monthly bill is $250,000, so you set your billing alarm for $251,000, well, day 2 of the billing cycle, you hit $250,000, you've lost $250,000. You got to figure out why you spent that much in the first 2 days. You still have the other 29, 28 days of the month that you're going to still spend about $250,000. So there is a caveat there, but billing alarms can alert you to some of those behaviors in the cloud environment that are a little malicious or just unauthorized. Okay, so let's talk a little bit about vulnerability assessment within your cloud environment. Each platform has their own built-in vulnerability assessment tool. Does this mean that's all you need and you can get rid of your traditional vulnerability management program? No, it doesn't. But you can use this for areas where there might be some gaps with your traditional agent-based or network-based vulnerability scanning tool. Because, and I don't want to pick on one vendor, but there are certain vendors where you try and run the vulnerability assessment tool against, let's say, AWS Lambda, and it says, I have no idea how to handle that. I don't know. That's not what I was built for. I was built for systems. And so using that in correlation with your traditional vulnerability scanning tools, the different platforms have these tools like AWS Inspect, Microsoft Azure Security Center, and GCP Cloud Security Scanner. Those tools can be turned on with a check of a button, essentially, and it's going to come up with things that are a little bit more specific to the cloud platform rather than just network-based or agent-based scanning. So absolutely want to check those things. That's going to give you a great deal of insight. Okay, and so then how do you deal with some of these? And I bring this in, this isn't just related to cloud security monitoring, but just security in general, because I see a lot of organizations that do have security or vulnerability scanning tools. They are not dealing with the scans properly. And what will happen is that they'll run the scans and they say, great, I've got this tool, I spent a bunch of money on it, it's scanning. One client gave us a 400-page report and said, now what do I do with this? And I asked them, well, let me see your prior year scan and see what that looked like. Every vulnerability was still the same. I mean, there's a handful that were fixed, but 400 pages were pretty much the same from the prior year when they did their external scan. So the remediation part can definitely be challenging. I hear that. I understand that. There's different ways of handling that are outside the scope of this, but basically you want to start with being a little more proactive. You want to educate the developers, for anyone who has access to create, modify, change anything in your cloud environment, educate them to these vulnerabilities, because if you can stop them from creating the vulnerability in the first place, that's a whole lot less items that you need to now go remediate after the fact and deal with that, figure it out. So educating developers, DevOps, whoever is dealing with the cloud environments and has administrative access, or not just administrative, but has the ability to change, modify things. You want to educate them on the top vulnerabilities in cloud, how their actions may impact the organization. And then once you do have your report, you want to break those vulnerabilities down into manageable weekly to-do items or tasks. You want to give them out to maybe the developers, say, look, you caused this problem. We need to now correct this. Track those things. You can use to-do lists, project management tools, whatever they are, but you want to break that down, because that 400-page report, yeah, it's overwhelming. There's no way that you can get through those 400 pages and fix all the problems in the next 30 days or a year or whatever your cycle is. But having them in smaller bite-sized chunks, that gives your engineers, your analysts, your DevOps people something they can actually do. You say, fix this one thing. Can you fix it this week? Can you fix it today? Can you fix it tomorrow? Whatever that is, but break it down to smaller chunks. Understand the ramifications and agree upon an action plan, right? So even though there's a vulnerability that comes up in AWS Inspect, it doesn't necessarily mean you've got a lot more risk in your organization. So understanding that vulnerability really well. One of my favorite ones is in agent-based scanning that comes up every single time we do PCI work, is that they'll say, well, your Cypher suites are not up to par. And I'm sure someone's going to come out there and say, well, here's all the use cases and why that's super important. But for me, it's like, well, they're not even using this for most of its functionality. It doesn't really matter. And it's an isolated air gap PCI segmented network. The risk is super low. But PCI says we got to fix it. We got to fix it. So if you're not required to go and fix things based off compliance, you may want to take a look at that and say, well, this is marked as a high priority item, but if we talk about this, do we have other compensating controls? Do we have other controls in place that are going to mitigate this risk, where we don't need to go ahead and basically pull the rug out of our environment to fix this thing that the AWS Inspect is calling it is high priority or high risk? We need to evaluate that with our own organization. And that's where more of pen tests come in, because they're going to take all those vulnerabilities and they're going to say, well, yeah, you've got 400 pages of vulnerabilities, but I'm really going to focus on these 3 ones that are going to be quick wins and that are going to easily net the crown jewels of your environment. Okay, and then get outside help if needed, right? So you're not limited just to your own organization. There's plenty of consultants, third parties, professional services that can help remediate some of these things, and possibly faster than your internal staff could. Okay, let's talk a little bit about least privileged, right? I'm going to look at AWS. There's plenty of best practices, but I can't tell you how many times I still see this. You go into an AWS environment and Amazon, they basically said, you know what? Let's kind of like CIS. Let's just give you the top 5 things. Please just do these top 5 things for your IAM best practices. Delete your root keys, activate MFA, which everyone talks about, create individual IAM users, use groups to assign permissions, apply IAM password policies. These 5 things, just please do these things, right? And so each platform is going to have their own best practices, but you could see that they're trying to encourage users and consumers of the cloud platforms to follow some of the best practices there. And those are all easy wins that you can do. Next slide here. The other thing you do as far as granular IAM policies, I hear that this is a difficult thing to do. I hear that looking at JSON may not be your favorite thing to do, but if you take a look at the actual IAM built-in policies, you can see here that on the left-hand side, the Amazon S3 full access policy, they basically say if you give this, you only have 2 options, and this might change because AWS changes things daily and I can't keep up with them all the time. But last time I wrote this slide about 6 months ago, we can see that there was 2 policies for S3. You can either give full read access or full write access. So if a developer says, I need to create an S3 bucket in the background for this application we're working on or to store things, you say, okay, I'll either give you full read or full write access to all the buckets. And if you start thinking about that a little bit, wait a second. So this developer, the default policies, I either give them read or write access. If they need to write to one bucket, I'm giving them the ability to add, modify, change, delete things in my security buckets, my CloudTrail buckets, my logging buckets, my PII buckets, my everything else buckets. I'm giving them full read and write access to that. That could be a bit dangerous, right? But these are the built-in policies that are there. So considering things that of possibly building this out a little better, and on the right-hand side is a custom S3 bucket. So you might say, no, I'm not going to give my developer access to my security logs and let them delete things. Instead, I'm going to give them specific actions to specific buckets. And you could write these by hand, or there are plenty of generators out there where you can build these out and give read, write, access, view objects, blah, 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 all these different permissions granularly. But this is something that you need to do. I would recommend staying away from the built-in policies just because it's giving people access to everything and too many actions on those services. Okay, and so then some other things you can take a look at. Within AWS, you can look at the credential reports. You can download these and you can find things like stale accounts, right? So most of the time in our Active Directory environments, we're looking at accounts that have not been logged into in a year or 2 years, or administrator accounts that are stale, or service accounts. Same kind of thing with continuous monitoring of your cloud environment. You need to be looking at least monthly at these reports and look, wait a second, these service accounts or tokens or whatever haven't been logged into in X number of days. We need to block them, turn them down, whatever that is. And then you can also find unauthorized users that possibly you didn't authorize to set up there. You can look at MFA and see if all your users are using MFA, which ones don't. A lot of different things that can come out of these reports. So I highly recommend downloading those and monitoring them. Okay, and so let's take a look at cloud accounts. So the goal is principal least privilege, as it is with a lot of other things in security. It's often a battle between business need, least privilege. Developer says, well, I don't want to have to contact security every single time I need a new bucket, or I need this, or I need that. Just give me full control. AWS provides over 2,500 permissions, different types of permissions. Granular control means complexity. And this is why I think most organizations are in this area. It is. And I'll be the first one to admit it's difficult to go through all the permissions and understand, well, what does object ACL read mean? And trying to understand that fully and the complexity of that, what the consequences are or the benefits of having a certain permission or not the other. It's a lot of work. And then complexity also means basically that you're going to have human error built into that. And so that's something you need to monitor. And so one glove doesn't fit all. So developers don't need access, as I mentioned, to the entire cloud platform. They don't need access to every single service. They don't need access to CloudTrail and your logging and security tools and stuff like that. There's separation of duty there. They don't need access to, and all developers don't need access to the same thing. So you might have one developer that's working on one project and they need access to XYZ, and another developer that's working on this project and they need access to ABC. So AWS Access Advisor is a tool that's built in there, and it shows if and when IAM has access to service. And why that's important is that if you're giving permissions to a developer, or I keep picking on developers, really anyone, and they're not using that service, why are you letting them have access to that service? If they haven't touched it in 30 days, 6 months, a year, 5 years, why do they need access to that service? If they have access to that, that means either an intentional or unintentional mistake may happen. So to build on that even more, Netflix puts out some awesome tools. They've expanded on Access Advisor. They use a tool called Aardvark and RepoKit. And what that does is that they deploy a role-based permission. So they say, okay, you're a developer, you'll get access to, let's say, S3, EC2, and this amount. And they'll put some parameters around that based off of what they see as best practice. They then review access to services and sub-services over time, for example, 6 months of time, and say, okay, so this default developer role, how is it fitting this user after 6 months? And they see, well, they've only used 3 of these 10 services that we deem necessary for most developers. We're now going to revoke those unnecessary or unneeded services. So those are free tools on GitHub that you can look at, or you can kind of apply this in your own way using AWS Access Advisor or whatever cloud platform tool you have. And you can take a look at that and say, well, I've been giving full access to these S3 buckets, but they only are using this one S3 bucket. Let's start, using least privilege and restricting their access to some of these services and even the tools that we have out there. Okay, let's talk about secure configuration. So not all CIS cloud benchmarks are verifiable programmatically. So what that means is that there's tools out there where they say, hey, you just basically give us some programmatic access to your AWS environment. We'll check everything and make sure your CIS controls are in place. You're doing everything right. That's fine. I got to tell you from experience, these third-party tools, they'll get about 85% there, but it's important to know that they're not going to be able to verify everything. So for example, use of the root account. They might be able to trigger on the use of root account, but infrequent use or how much it's used or why it's used, they can't really verify that. So it'll get you 85% of the way there using one of those third-party tools, but you're still gonna have to do a little legwork yourself, about 15% of that. So for example, you can look at the benchmarks that CIS provides for free, right? They might be 1,000 pages. It's great reading. I recommend it for everyone. Takes a long time, but you really start understanding these controls better. So they do make these benchmarks specifically for cloud. For example, for AWS, they've got their own benchmark. 1.1 says avoid the use of the root account. You get scored for that. They describe it. They give you the rationale, which is awesome. And this is why I recommend even junior security professionals, your analysts, your engineers, your interns, they read these documents if they're getting access to the cloud environment, because not only are they just saying, okay, we shouldn't use root account, but there's actually a rationale behind that of a lot of security experts, and they take time to write that out. They also then show how that. So this helps with your threat hunting, your incident response, your blue team activities, because you now say, okay, well, I can see if this has ever changed. How can I audit if the root account is being used? They give some information on that. They give some remediation recommendations, and they even give references. So if you want to go look more into that and see, okay, I'm curious about this, I want to learn a lot more, they give you the link there to the AWS docs that you can read about. Right. And then there's other tools there. This is just one that I took a screenshot of that will take those best practices, those benchmarks. It'll score you. It makes it a little easier rather than reading the 1,000-page CIS document and going line by line and learning about that. And also, you can't manually audit everything that's going on in real time as fast as if you had a third-party tool. So now let's talk a little bit about monitoring and logging. I'll briefly touch on this. I mentioned last year for RMISC, we had a talk about this. Evan Bradall and myself, we brought up AWS Cloud Security Monitoring on the dollar menu. We talked about free, easy ways to do some of this stuff. So I pulled this slide from last year's talk about the different AWS logs. And the reason for this is that I won't go as much detail as I did last year, but the reason is that there are so many different types of logs, and you need to understand what those logs generate and how to identify evil with those logs. And so there's also an importance of this in that there's delays. A lot of times people think, well, my sys logs, my firewall logs, I do something and immediately I have that log or that paper trail of what happened. Well, certain logs within AWS, and again, these may have changed since last year, but ELB logs, they could be a 5-minute delay. VPC logs, they could be a 15-minute delay. So if you're doing instant analysis, or even let's say CloudFront, the cache request logs, they could be up to 24-hour delay on some of this stuff. And so understanding of what you're logging, what it looks like, what's normal, what can you get from each of these logs, and then some of the delays are important, because think about SIM or correlation. If you've got a delay of 24 hours and you think there's some suspicious activity, well, you might have to wait a day to get some of those logs. Okay, and so with CloudTrail, something that every organization, if you're using AWS and the equivalent in any other cloud platform, you need to turn on. And there's some defaults. And again, these things constantly change. And this is my love-hate relationship with cloud security, is that I'll learn about something, I'm like, this is great. And then 2 weeks later, it's completely different because the cloud platform has changed it in the way it works. So as of beginning of this year, at least, CloudTrail is enabled by default finally. But there's a 90-day retention on that. So if you are going back to our slide of the M trends and the dwell time, we saw external notification, or the time that we're breached to the time we have identified the breach externally, it was 150 some days from the M trend that I had on the slide, right? The dwell time was over 150 days. And so if you want to be able to look back at your logs 150 days, your default level of logging with CloudTrail is only 9 days. So you're going to miss a lot of that stuff. Also, external report of, I just mentioned that, of breaches over 100 days. Each region's logs are kept in its region's bucket. So if you're interested in correlating and you're using lots of different regions, for example, using South Korea and Oregon and North Virginia, et cetera, they're going to be in buckets within each region there rather than one central view. So you may want to take those logs and ship it off to a SIM or some central logging and be able to see that movement or the access across all your buckets and not be siloed as much into each region. Okay, and so some of the things that I talked about again last year, the data can be overwhelming. But what you can do with some of this stuff is you can set up alerts either through a SIM if you're shipping those off, or if you want to use built-in tools again, continuous monitoring. CloudWatch, they've drastically expanded the ability of CloudWatch since I built this slide. There's a lot more security related events that you can trigger on those API calls, and you can alert your security teams through webhooks, through emails, etc. The default, though, is that there's about a 15-minute delay with these CloudWatch alerts. So you are a little bit behind versus if you're looking at possibly CloudTrail, you might get a little more real-time visibility. Okay, and then on some of those things when you're building out some of these logs and alerts is that think about actual events. Going back to the slide that I had with the 28,000 VPC rejection flow logs that were identified in a 24-hour period, how can you make these things more actionable? Think about bad situations. Think about the slide where I had those big breaches from Verizon and Capital One. What are some of those events that you could put in your cloud environment where you detect those things? Going back to the example I gave, if you start using any service in the South Korea region of AWS, is that normal evil? If you answered that question as evil or potentially malicious, then what I want you to do is think about some type of alert where anytime a service is created outside the regions that you use. Those are actionable events. Even if it's a developer or an eager person on your team that goes out there and plays with some services in another region, you're getting notified about that. I don't want to go into a SOC, or I don't want to go into a NOC, or I don't want to go into any security analyst inbox and see 28,000 alerts. I can't not act upon that type of event. But what I want is something like your cloud-based domain controller. The security group was changed to allow 0.0.0.0/0. So anyone on the internet, full control or full access, or you modify any type of firewall rule on your domain controller or anything that's high crown jewel of your organization. And so going back and not just saying, yes, I can log everything and I can alert on everything. You need to come and think about these events that you can make actionable steps. I don't want to see more than 10 to 13 alerts going into my security analyst or security engineer's inbox that they need to act on. And I want 90% of those events to be something that I need to act on and that are legitimate, right? I don't want to just know every time someone logs into AWS. I do want to know when the root account logs in. I do want to know when there's a new account that gets overly verbose permissions. So those are certain things I want to alert on. Okay, and then some other things, the S3 logs, right? If you gave one of those default permissions, whether it's full read or full control of your S3 buckets without granular permissions of your S3 buckets, everyone who has access to S3 buckets can now look at your logs. If they've got full control, they can delete it. So maybe consider doing things like MFA to delete your logs, your security logs, and limit access to those. VPC Flow Logs. Finally, last year when I talked about this, we gave workarounds for how to do full packet capture and stuff like that. Well, you've got VPC Flow Logs, so we can get SFlow and NetFlow type data. And now with VPCs, as of the end of last year, you can actually get full packet capture, which gives you more than just SFlow, NetFlow statistical data, where we have to make conclusions on the data. We can actually see inside of the packets, which are awesome. So same kind of things. Even if you do VPC flow or you use full packet capture, can you imagine looking at every packet across your environment? That's too much. So what do you want to do? You want to take a look at high fidelity things you can act upon. For example, clear text protocols. You want to look at things that are making GET requests or POST requests that are using quad IP addresses rather than a domain name. There's certain things you want to take a look at that are malicious that you can pull out and filter out a lot of that noise, and so you can act upon those events. Hey, just an illustration of how to create VCP flow logs. You just right click on the VCP in AWS, you generate that, and you really get some awesome data out of that. Not on by default, but something you can usually do. Right, and that'll give you alert, or you can start identifying events like this. And this is one of our customers where they were not listening as far as RDP, and they had RDP open to the internet. So unfortunately, what happened is that we could see things and looking at a 1 week. So this is May 6th through May 12th, 2019. These are the RDP connections. So we did statistical analysis on all the RDP connections, and we can see there that 3 IP addresses came from the same block of IPs, and they were all reverse. If you do reverse lookup, it was zservers.ru. So there was thousands of RDP connection attempts within a 1 week period. Without enabling VCP flow or anything like that, you're not going to see a whole lot of that stuff. Okay, so my final part of this talk, and probably my favorite piece, is now that you kind of see that there's a lot of stuff built into these cloud platforms, and you see that you need to build a defensible cloud environment and not just turn on all the logging and alerting and stuff like that is that you need to have a defensible environment. You need to have those different corridors, the dry moat, the wet moat, the boiling oil, the boulders that come down, segmentation, all that stuff so that you can properly defend your cloud environment. And then you can continually monitor it. And so some of those things are hard to do, right? When you've got a lot of activity in your cloud environment, well, you might say, well, a change to the security group is something that happens daily. Okay, I get that. So consider doing things like detecting high fidelity events that you set. When I first got into security, I thought honeypots were kind of a cool thing, but it was really a joke. Now I'm starting to see that honeypots are actually an incredible use, and not just honeypots, but I call them honey things now. And so being able to set up traps that generate those events that are 99.99999% actionable are incredibly valuable in an organization, especially when there's alert fatigue. So each organization will need to tune their detections differently. I can't give just a blanket thing of alert on this, do that. I can tell you, for a lot of our organizations, we create honey users. That's one example. So we create a user and an admin that follows the naming convention of any organization that we're working with. And we set the login time to basically never, and we create a really complex password. But anytime someone attempts to log into that user, which doesn't even exist, it's not a real person or a real admin, we are all over that. And that alert, if that comes up, that's like a break glass alert because someone's trying to do password spraying, they're trying to brute force, different things like that. It's not just fat fingering, right? And I tell a lot of my students when I'm talking about basic security concepts and brute force is, if you see a failed login event on your Windows domain controller, is that someone that typed their password incorrectly, or is that a brute force attempt? I can't tell the difference. I could go talk to the person, but just getting that one event or that alert, I cannot make a logical conclusion on that. You might say, well, if you get 100 of those within 5 minutes, that's probably brute force attempt. Sure. But I've also seen tools like Veeam, and I don't want to pick on them alone, but there's vulnerability scan. There's other tools that can generate a large number of failed login attempts that are legitimate use cases as well. Maybe just the password's wrong or it expired or something happened there. So the alerts need to be actionable in your cloud environments. This allows you to continually monitor your environment. As I mentioned, shoot for less than 10 alerts per day per analyst or engineer that's taking a look at these alerts. Some sample high fidelity events or alerts that we help set up for some of our customers. We alert on activity in regions you're not using. As I mentioned, if you are not operating any services in Africa or South Korea, why would you not alert when someone spins up a service or accesses that region? Create an alert on access to honey buckets. I'll show you a slide here in a second of how to create a honey bucket that doesn't exist, but it's got your company name or it's similar to a name you might use. And if someone's basically brute forcing that or trying to get access to that, it doesn't really have production value, but you're getting alert that someone's interested in your buckets. You might want to alert on things like CloudTrail being disabled. By default, CloudTrail is enabled, but if you disable it, there's no alert for that. So if the attacker gains access to your account, disables CloudTrail, they're no longer being logged in the activity that they do. So go a step further, not just alert on that, but use Lambda to then re-enable CloudTrail so they can't disable that. Alert on attempts to delete logging buckets. So if I have a CloudTrail bucket, I've got other logging buckets, I don't want anyone touching those, and I definitely don't want them deleting it. So if they try any actions around delete or access that they're not allowed to, I want to be alerted to that. That's something I can act upon. And then alert on access to foreign non-whitelist IPs. You can set up IP restrictions on your buckets on some of your other services within Amazon. So why not start getting alert on some of those things? Like if someone accesses it, if you're a company that just works in Denver, your customers are in Denver, your employees are in Denver, then why in the world would you not alert when North Korea, Russia, China, Iran, et cetera, are all trying to access your S3 buckets? And then alert on machine-generated names. You can use plenty of tools like freak.py, which is built by Mark Baggett. So it's looking for things, whether it's an S3 bucket or a tag or anything that is generated that's machine-generated, and it's not following human pattern of creating words or bucket names. So it's randomly generated, and you can alert on that kind of stuff as well. And then so for a honeypot, some of the things that I've done in a lot of our client S3s, or sorry, in their AWS environments is that we'll put in a public honeypot and we'll basically monitor the different attacks for things, not necessarily public, but we'll also put it in sensitive like PII type of VPCs. And that way, when there is access to a restricted network, then we're getting alerted on some of that stuff. And we disguise it pretty well to look like a lot of the other servers or instances or services that they're using. The first honeypot was created way back in 1998. And the intent is basically really if someone's accessing the service or services or tool, you've got a high fidelity event, something you can really act upon. And so it decreases the number of false positives. It's not like, hey, this person failed to log in or this happened or that happened, where you get hundreds of those alerts. These are things that you need to act upon. So it requires less data collection. I don't need to, if rather than a domain controller that's generating 15 gigs of logs a day, my honeypots, it shouldn't really be logging much of anything because no one's touching it. And the time it does get touched, then I'm ingesting that data. So the cost to ingest that data and retain that data is really low as well. It's a great way to create actionable high fidelity events. You can use free or paid tools like Open Canary, throw that up and it emulates a bunch of different services, or honey buckets is pretty much the last piece I'm going to talk about here. But the honey buckets, there's a tool out there that you can create something. For example, if I had Richey May DB backup, maybe I try and name it with our company name in it, or things that I think people might be looking for. If I'm Verizon, I'd have a bunch of different variants of the Verizon name in my buckets. And then you allow public access. You enable detailed logging so you can see the source of where the access is coming from, or the request to delete, or list out contents of that bucket. And you can even take a step further. You can use Lambda functions to use SNS to alert on that. But again, there is free tools out there where they generate these, and they've got webhooks that'll trigger that and notify you when someone tries to access these potentially proprietary buckets. Right. And then you can even use things like this is a screenshot here where you can then send those alerts off to your SIM or your Elastic Stack or whatever it is. But these are the type of alerts. It can say 673 attempts to access the S3 bucket. You've got a bunch of different these buckets. It gives you the IP addresses, and you can see if you're being targeted by a group or certain threat actors, going back to the art of war, knowing the threat actors that are coming after you. You could also have honey tokens, which are fictitious database entries. You could have names, credit card numbers, PII, but you're alerting on that stuff, right? Because if there's normal behavior to view a database or an S3 bucket, because you need to have that functionality to operate the business, well, that's fine. We can't necessarily alert every time a customer credit card's accessed in the bucket because it needs to work that way, and there's thousands of those events. Well, okay, then create a specific entry in that database, in that bucket, or wherever you're talking about, or service, and you're alerting on that very specific name, credit card number, token, whatever it is, and that's then generating an alert when that's accessed. And then honey creds, right? Last slide here. You can use honey credentials, create that AWS IAM credential without any permission, so it can't access anything, but it's a valid user. You could set up CloudTrail, CloudWatch, or SIM, whatever it is, to alert on that stuff. Place those credentials in different locations. I wouldn't necessarily recommend on like GitHub, just because it's going to get, people grab that pretty quickly, but you could put it on your developer systems and tell them, don't touch this. But if an attacker gains access to their system, they look at the directory of .aws, the hidden directory, and they look in the credentials file. Well, they're going to see that, try and use that. Your developers know it's not legitimate, but anyone who accesses their laptop or gains access to the machine, they try that, you get alerted, that machine's compromised. And then you could obviously automate that into some type of playbook. That, I know I went a couple minutes over there, apologize, but that concludes my talk on cloud security, continuous cloud security monitoring. I'd love if any of you watching this can connect. If you have questions, obviously you can do it so in the chat, but afterwards I'm happy to collaborate, communicate on LinkedIn, Twitter. Feel free to reach out.
Thank you, Michael. That was incredibly useful. Are these slides going to be available if somebody contacts you? Yeah,
I normally, if someone at a traditional in-person conference, anyone comes up after and wants a copy, I can send that over. If they reach out, LinkedIn, Twitter, I'm happy to send a link or give them the PDF of the slides.
Okay, great. We do have a couple of questions. We have a little bit of time. We'll take 2 questions. And one of the questions is, you talked about there are 25,000 different permissions that you can set up on AWS. Is there any documentation behind that?
Yeah, so docs.aws.com, you can search there, and they've got, AWS does a great job documenting. My only complaint about it, they document everything, is that it's a little bit dry sometimes. And I think that's where some of the security issues come in, is that it's a little tough to understand, especially if you don't have a lot of experience with that. So they do document everything. You may also need some third parties to kind of give it to you as a, dumb it down a little bit. I don't want to say that, that phrase, but it's got to be in a way that's a little more digestible rather than it's almost like reading a car manual. It's a little bit dry.
Okay. All right. All right. The other question I have is, couldn't you set up controls on your AWS account to have basically a single user or a single account? Well, not an account, a single role that would basically have to approve the cloud usage. So you wouldn't have these, bucket here, bucket there, and a $250,000 bill.
Yeah. And so I think go back to one of the best ways that I like dealing with that is the Terraform route. And so if you say, yes, developers and anyone who needs access to the environment, and this is across all cloud platforms, develop what you need, write this in the Terraform language, submit that to change control. Other people are going to review that, the change control board. They're going to say, yes, we'll submit it. And then that one person or those few people have access to actually commit the changes. That's going to then push that into production or a test environment or whatever the workflow is for that organization. But that limits it as well. And you can then build out your environment in Terraform and get a second set of eyes on it rather than just add, and you spun up $50,000 worth of resources.
Okay. All right. Well, thank you, Michael. This has been incredibly interesting. I think a lot of us would like to see you again in some other fashion where you do a workshop or something, because this is really incredibly deep. So
absolutely. Yeah.
Yeah. So thank you again for spending time. Thank you to everyone who joined us today. And we look forward to having you participate in further events. So thank you, Michael.
Thank you. And thank you for putting this on with everything going on. It's great to have different outlets to continue learning and to see some of the stuff. So thank you to everyone behind the scenes who's put this on for the whole community.
All right. Thanks. Bye-bye.